Hi students, welcome to HSC Earth and Environmental Science and Module 7 Climate Science. This is video 15 and the first in our section on human activity and the greenhouse effect, and this one we're going to be looking at the anthropogenic greenhouse effect. So we need to be able to distinguish between the natural greenhouse effect and any anthropogenic greenhouse effects. So this is the first I guess of the videos that are going to be produced under this third inquiry question, or this third area that we're looking at in terms of climate science, which we've broadly called the influence of human activities on changes to climate. The inquiry question itself is there scientific evidence to show that human activity has led to a variation in the Earth's climate since the Industrial Revolution? So that's going to be our focus for the next few videos, not just for this one. What we'll try and do in this video is just to set things up a little bit and then to move us forward to see what sort of things we can look at in terms of human activity and its relationship to the greenhouse gases. So I guess the first thing we need to do is we need to sort out science from pseudoscience, and definitely there's some fantastic science fiction works, some great movies that have been produced around what might happen to the planet at some point in the future. And I guess the fact that there's a lot of confusion between what is a natural greenhouse effect and where human activity actually impacts on some of these levels, that's where there can be a great deal of confusion and misinformation. Firstly, some of the people don't always have sufficient scientific training to be able to argue the case sufficiently. Those that do sometimes have vested interests, and particularly those that are involved in the fossil fuel industry. And the science is very, very clear. It's global. It's got a huge amount of support. It's had that support for some considerable period of time. And despite the fact that there's been a lot of information that's been put forward, politically driven or personal ideological forces that have actually generating some of that discussion. So what we really want to do here is separate some of the politics and some of the ideology from the actual science. I've just put my soapbox away now, so we'll get on to things like the natural greenhouse effect. Now, this doesn't require too much explanation because we've talked about it so often that I'm hoping I can just sort of zip through it and you'll be fine. The whole point is this: the Earth warms up because it receives solar energy from the sun. That heat energy comes usually to the Earth in the form of shortwave solar radiation, and that passes through the Earth's atmosphere and gets absorbed at the surface of the Earth. Differentially, partly because of the albedo effect and the white snow and ice that reflects some of that radiation, but also darker surfaces like the oceans and also on the land, which is also very good at absorbing some of that radiation. That solar radiation has warmed the Earth's surface, then it re-radiates that energy back into space. The difference is that the energy has slightly changed in wavelength. So it's now more of a longer wave, infrared radiation, that sort of part of the spectrum. Now, we also know that there are a number of important atmospheric gases, and what we want to do in this next little section is we don't just concentrate on carbon dioxide, because it's certainly not the whole story. In fact, in some ways, the amount of water vapor in the atmosphere is even more important in terms of the greenhouse effect than carbon dioxide. But we also want to put a tick on methane and some of the nitrous oxides that are also contributors to this effect of the natural greenhouse, because they all absorb some of that radiated energy that's returning back from the surface of the Earth. Now, when the energy is absorbed by any molecules, any atoms, it then re-radiates again. So energy comes in and energy goes out. Now, some of that energy is going to go back into space, but the energy in radiation, if you think about radiant heat, that comes out in all directions. And so some of it is going to come back towards the Earth, some of it's going to go out sort of around the atmosphere, and other bits are going to go up towards space. The key is that there would be more of that energy escaping into space if those greenhouse gases weren't there. So this is the important thing about these gases. The presence of these gases holds in some of that energy, and it helps the whole of the planet to stay a little warmer. That sort of trapped solar energy is what keeps a bit of heat in the lower part of the atmosphere. And of course, that's one of the things that makes life ideal. So what we want to talk about is we want to talk about a concept known as equilibrium. So equilibrium is basically the idea, it's like being on a seesaw, okay? You can't work a seesaw very well if one person is much bigger or heavier than the other person, because you get an imbalance. One of the things that we've looked at in terms of the greenhouse effect and the changes in atmospheric conditions, climates, in terms of temperature variations or carbon dioxide levels, all contribute to this idea of a dynamic balance. So the idea is that the rate at which the energy is absorbed by the Earth is roughly balanced by the rate at which it's emitted back into space. So it's not a perfect some comes in and some comes out. Basically, the proportions of those are roughly similar over time. If more comes in than is going out, then we get a heating effect. If more goes out than comes in, then we're getting a cooling effect. And so this is what shifts our Earth thermostat up and down based on how much of the radiation is remaining in the atmosphere and how much is escaping back into space. Provided the amount of greenhouse gases in the air stays the same, then this rate of energy arriving and leaving ensures that we have a consistency, ensures that we have a maintenance of equilibrium. So we get these levels sitting fairly nicely, fairly even. The problem, of course, that we have is that prior to the Industrial Revolution, which is around the late 1700s, the natural greenhouse effect maintained the average temperature of the Earth's surface at around 15 degrees C. Now, remember, this is an average, and we've got polar regions and we've got deserts. So this isn't 15 degrees everywhere. This is just kind of averaging out at a value. And it gives us a baseline. It gives us something to use for comparison when we talk about some of the effects that have been created as a result of some of this. So this is our baseline, and this is where we start to look at the difference between what we would expect from a natural greenhouse situation and where anthropogenic greenhouse, where enhanced greenhouse or the addition of certain gases to the atmosphere may have changed those compositions, changed those proportions in the atmosphere, and therefore shifted that equilibrium, and continues to do so today. One of the most important things, I guess, that we need to be aware of is, and I've talked about this in previous videos, and that's the rate of change. It's not whether or not things are changing, it's how fast they change. And in this course, we've looked a lot at geological time. We know that this is a huge time scale over which natural processes occur. And we know that we can see certain cycles in the Earth's atmosphere, certain changes, certain effects of those cycles in terms of greenhouse or icehouse conditions, and these have happened to the Earth consistently over long periods of time. Higher concentrations than what we have seen have been present in the Earth's atmosphere in the past, and certainly considerably lower concentrations than what we have currently have also been observed in the past. And we've seen this cycling between a maxima and a minima, which isn't always the same and is based on a number of different factors. And we've explored a lot of those factors in this module already. Over geological timeframes, life on Earth may gradually adapt, may start to shift in such a way that organisms are able to cope with these slightly warmer conditions, or more rainfall in certain areas, less rainfall in other areas, some inconsistencies around the climates, and adapt some sort of strategies to be able to survive. The problem is the equilibrium that's existed even for just the last 10,000 years or so, which is, as we've talked about, extraordinarily recent, extremely recent, very, very short period of geological time, is now being disturbed at such a rapid rate that adaptation may not be possible. And this, where species are unable to adapt, leads them towards extinction. There's a huge amount of wisdom that's tied up in indigenous culture. And it's not just indigenous culture in this country, it's also indigenous culture in places like the Americas. One of the famous sayings is around whether or not we inherit the earth from our ancestors or whether we borrow it from our children. One of the things that's very clear when we look at this whole area of greenhouse natural versus enhanced, natural versus anthropogenic, is that we see that humans have existed on the planet for a very long period of time, have understood how important the relationship is with country, how important it is to care and to conserve natural resources and not to exploit them. And humans have lived on this planet for a very, very long period of time. It's only in the very, very recent history have we actually started to exploit our planet in such a way that we're doing damage that we may never be able to undo. And this is the key focus of this section of work in this module. Thanks for watching.